Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular video, we are focusing on this S1 paper. It's a midterm exam of 2024. And let me tell you what topics are there in this particular paper. There is probability, there is perms and permutation and combination. There is probability distribution, which the official name of this particular chapter is DRV, discrete random variable. And then there is geometric probability distribution, and yes, there is binomial probability distribution. So that's also part of DRV. And let's look at this paper. It's for 1 hour and 15 minutes. And the marks assigned is 52 marks. So approximately 30%, not 30%, that's too low. That is 30 marks out of 52. Anything below this, that is not good. So when you try out this paper, do try it out and then look at the solution. So let's get started with the first question. It's about binomial probability distribution. In Greenton, 70% of adults own a car. A random sample of 8 adults from Greenton is chosen. So now you have to realize whether it's binomial, whether it's permutation, combination, and all these things. So you have to realize it. This is the number of trials which goes over here. This is the probability of success that goes over here. X is the variable that is for this thing. The number of cars and everything. Find the probability, the number of adults in the sample who own a car. So number of adults in the sample, that is X, is less than 6. So probability X is less than 6. Probability X is lesser than or equal to 5. 5, 4, 3, 2, 1, 0. Too much to calculate. So what should you do? You should calculate the probability of 6, 7, and 8 and then subtract it from 1. First add and then subtract from 1. Now, let me write down the formula in case anyone needs that formula. That formula is X follows a binomial distribution in comma P, and probability X is equals to R, that is NCR, success raised to power of R, failure raised to power of N minus R. So let's look closely over here. The probability of success is 0.7. So 8C6, 0.7 raised to power of 6. 8C7, 0.7 raised to power of 7. 8C8, 0.7 raised to power of 8. The difference between 8 and 6 is 2. The difference between 8 and 7 is 1. The difference between 8 and 8 is 0. The total of these powers should equal to N and work in at least 4 SF. So that is the working level of accuracy, so that the final answer should be given to 3 SF. That's how the first question is done. And it's for 3 marks. So basically, I'll give the marks in this manner. Basically, you have to calculate these 3 probabilities and add it up. That's like 1 mark. Subtraction is like 1 mark, giving you the final answer. And 1 mark is for these 2 things. So basically writing down the distribution, and even more important is that to determine what is the inequality in which you will be calculating the probability. The second question, that is about tree diagram and conditional probability. Maria chooses toast for her breakfast with probability 0.85. So it could be Maria, it could be Maria, that's your choice. If she does not choose toast, she has a bread roll. So it's either toast, T for toast, B for bread roll. I have given the key over here. If she chooses toast, then the probability she will have jam on it is 0.8. So toast, have jam, 0.8, no jam, that is 0.2. If she has a bread roll, then the probability she will have a jam on it is 0.4. So 0.4 and 0.6. So it could be toast, jam, toast, not jam, bread roll, jam, bread, not jam. The first 2 marks are for drawing this tree diagram. So basically 1 mark for this and 1 mark for these things. Given that Maria did not have jam for breakfast, that means our condition is toast, no jam, bread, no jam. Toast, no jam, so 0.85 into 0.2. Bread, no jam, 0.15 into 0.6. That is these 2 things. And then this is the condition. Condition goes down in the denominator. and find the probability she had toast. So this is the relevant portion. That relevant portion goes up. So now this is 0.17, this is 0.26. I would prefer leaving the answer in the exact form. Do not challenge yourself or the examiner by just working your calculator. There is no need for that. Yes, the question was in decimal, but this answer is coming out to be exact. So this is perfect. This is 10 out of 10 for leaving the answer in the exact form. Third question, that is DRV, discrete random variable. The random variable x takes the value -2, 0 and 4 only. So it only takes 3 values. How is the probability calculated? When x is -2, the probability is 2p. When x is 0, the probability is p. When x is 4, probability is 3p. So just put it in a table. Add up all the probabilities. The sum of probabilities is 1 because it's a DRV, R for random. Every single probability is taken into consideration. The value of P comes out to be 1/6. Find expectation, find variance. What's the formula for expectation? That is sigma XP. That is take this value of X, multiply with this, take this value, multiply with its corresponding probability, add it all up. So I first worked in terms of P. I found it easier. Then I inserted the value of P. You could leave the answer as 8/6, 4/3, 4 is exact, or 1 whole 1/3. Fractions are supreme. Fractions are beautiful. Fractions are exact. The next thing is variance. For variance, I need to calculate expectation of x square. So a column over here, x square, that is 4, 0, and 16. Or if you don't want to draw a column or a row, so therefore sigma x square p, just write the value of x, square it, value of x, square it, value of x, square it, and then multiply it with the corresponding probability. This comes out to be 56p, 56 into 1/6, that's 56/6 or 28/3. Again, leave the answer in fractions. We are focusing on variance, that is expectation of x square minus square of expectation of x. Just use a calculator. You can also write in the exact form. This is 3SF. And that is the answer. So let me just write 3SF over here. How are the marks given? For 2 marks, I mean, that is basically writing this thing equal to 1. That's 1 mark and this is 1 mark. 4 marks, let's say 1 mark for expectation, 1 mark for expectation of x square, and 1 mark for writing this formula, 1 mark for this answer. So that is how the marks could be assigned. Now, maybe sometimes the examiner could give 1 mark for this and 3 marks for all this thing together, or maybe 2 marks for this or 2 marks for this. So that is also a possibility. The mark scheme is there at the end. So now it says DRV, probability and or permutation combination, because I've done this question in 2 ways. Andy has 4 red socks, 8 black socks. So I don't have the black color as such in highlighter, so I used blue. He takes 2 socks at random from his drawer. Find the probability the socks taken are of different color. The denominator 12 reduces to 11. Naturally, this is without replacement. When you are choosing 1 sock, you are not replacing it. 4 is for red. Out of 4, there is a choice out of 4. There is a choice out of 8. But the order could matter. So in probability, this is permutation. This is probability. The answer is 16/33. So this first method, let me write it down. This is based upon the concept of probability and permutation. Second method is based upon the concept of combination. Order does not make a difference. Without any restriction, 12C2. Choosing 1 red and 1 blue and means multiplication. This is 32/66 reduces to 16/33. A beautiful question done in 2 different beautiful ways. The random variable x is the number of red socks taken. You can have a 0 red sock, 1 red sock, or 2 red sock. Draw up the probability distribution table. So I'm doing it by combination. 4 red, 8 black. It could be 0, it could be 1, it could be 2, it could be 2, 1, 0. These are the number of different ways. The total is 66. Double check that 12C2 is coming out to be 66. It was already calculated over here also. So be a bit vigilant. Probability x is equals to 0, that is 28/66. X is equals to 1, 32/66. That's calculated in part 1 already. And probability x is equals to 2, 6/66. And they are not asking for, yes, they are. They're asking for expectation. Expectation is sigma px. That is just the way that we have done. So that's how these questions are done. Question number 5. A pair of fair coins is thrown repeatedly until a pair of tails is obtained. So we have tail, tail, we have head, head, we have tail, head, we have head, tail. There are 4 possibilities. It's fair, so each probability is 1/4. The random variable x denotes the number of throws required to obtain a pair of tails. So pair of tail, the probability is 1/4. And yes, it's a geometric probability distribution because the number of trial is not given. The word until is there. Until and unless you achieve success, you keep on going. There are no number of trials mentioned. It's infinite. P is 1/4. Expectation of x is reciprocal of probability. This comes out to be 4 for 1 mark. Find the probability. Exactly 3 throws are required to obtain a pair of tails. That means the first 2 will be failure. The last one will be success. This is the probability of success. 2 failures, 3/4 into 3/4. That can be written as 3/4 square. Left the answer in fractions because fractions are exact. Find the probability. Fewer than 6 throws are required to obtain a pair of tails. Probability x is less than 6. Which is probability x is lesser than or equal to 5. You don't have to use a whole long method. Just use this thing. Very handy. Probability x is less than or equal to n. It's necessary that I have a less than or equal sign. Is 1 minus probability of failure raised to power of n. I left the answer in fractions. I left the answer in decimals according to. So now let's continue with this paper. Now this question is about permutation. How many different arrangements are there of the 10 letters of the word regenerate? The very first thing that you need to do is to break it down. R-E-G-E-N-E-R-A-T-E. So we see that there are 2 R's, there are 4 E's, and then there is 1 G, 1 N, 1 A, 1 T. I have labeled or highlighted the R's with the red color, the E's with the blue color, and G, N, A, T, one category in green color. First thing, 10 letters, they can be arranged in 10 factorial ways. But there are identical objects. Alphabets are identical, digits are identical. Let me write it down. Alphabets, also known as letters, they are considered identical in the same manner as digits are considered identical. Anything else, they will mention it. For example, it could be cans of cola. That will be identical. It could be whiteboard markers. They could be identical, and so on. Sometimes you have seen question in which they talked about cups, and in those questions they talked about different, they talked about identical. So anything that will put you in a dilemma, they will mention it. Coming back to this, this is 10 factorial divided by 2 factorial for the R's, 4 factorial for the 4 E's. So that's an E written over there. Let me just write it properly. So that's an E over here. Okay. And this answer is 75600. This answer is exact. There is no rounding off. Now the next part, I think that is the most important part of this particular question. That is part B. Let me highlight this. Now part B says, how many different arrangements are there of 10 letters of the same word regenerate in which the 4 E's are together? So when we talk about together, we think of a box. And the 2 R's have exactly 3 letters in between them. So there are 3 letters between the 2 R's. So now this is the condition, and then naturally the condition that 4 E's are together. Now the first thing, the 4 E's are together in a box. I wrote an R, then 3 green for the GNAT. I'm using the same color combo. And then a green at the end. So the E's are on the extreme left. Still, the E's are on the extreme left. And what I have done is that I have switched places. Basically, R, 3 greens, R and a green. So now this is like green, R, 3 greens and an R. So basically, this is mirror image of one another. Now let's continue with the same streak and let me take it to the extreme right. So if I look at this, R, 3 greens, R and green, R, 3 greens, R and a green, I just took it to the other side. So line 1 and line 3, they are related. So let me just highlight it like this. So line 1 and line 3 are related. They are mirror image of one another. Similarly, line 2 and line 4 are related. So how are they related? This is 4 E's on the left, 4 E's on the right. Green, red, 3 greens and red. And now this is green, red, 3 greens and red, and these two are related, 2 and 4. Now line 5 and line 6, I have deliberately left it open, so I want you to think, what other possibility is there? This is a condition, let me write it down, that there are 3 letters between the R's. That could be any one from G and AT. So G and AT, any one of those, and it should be stuck between these 2 R's. But we have to fit in these also. So what if I move this to the left and take this from here and paste it over here? Now, does it make sense? Yes, I think it is. The 4 E's are together. The 2 R's are there. There are 3 alphabets between the 2 R's from G and AT. So that is perfect. And similarly, let me also select this, push it to the corner and insert this in the middle and then readjust. So I think it fulfills the criteria. So therefore, this is also like the mirror image of one another. So let me highlight this. So 5 and 6, they are also related. And how they are related are 3 G and AT, any one of those 3, and R, the same thing. There is a green on the side, there is a green on the side. So how many lines do we have? We have 1, 2, 3, 4, 5, 6. Now in each line, what is the combination that we have? So for the E's, that is 4 factorial divided by 4 factorial, because nothing is happening because the E's are identical. And we are pasting R's and they are identical. So 1 R and 1 R, this is for the R, this is for the R. If you want to write, you can write 2 factorial over 2 factorial also. And what about G, N, A, T? They can be arranged in 4 factorial ways. So basically, this is cancelling out. This has no importance because after multiplication, it's 1. What do I have? This is 24. So what I've done over here, that's 4 factorial over 4 factorial for the E's, 2 factorial over 2 factorial for the R's, 4 factorial for G and AT, and there are 6 lines. 4 factorial is 24, 24 into 6, this comes out to be 144. So this was a question in which the 4 marks was definitely worth it. I think in my view, it should be worth more than 4 marks. So coming back to this, the third question, the third part, let me underline it again. It says find the probability. Now we are talking about probability and people do miss it out. So I have a habit of underlining it. That a randomly chosen arrangement of the 10 letters of the word regenerate is one in which the consonants G and RRT and the vowels alternate. So this we have done in class also, alternate. Now there are 5 of each. So there are 2 possibilities. It could be consonant, vowel, and so on. Or it could be vowel, consonant, and so on. So for the consonant, that's 5 factorial. For the vowels, that's also 5 factorial. Out of the consonants, there are 2 R's divided by 2 factorial. Out of the vowels, there are 4 E's divided by 4 factorial. And why multiply by 2? Because 2 options are there. This comes out to be 600. Answer of part 1, which is without any restriction, that is 75600. So 600 goes at the top, that is the numerator. 75600 goes at the bottom, that's the denominator. This is 6 over 756, 1 over 26, 126. That is the exact answer. Leave it as it is. No need of decimals. Question number 7. Now a table is given and probability is asked in something about mutually exclusive and independent kind of thing. In a group of 30 adults, 25 are right-handed. So this 25 goes over here. And there are 30 altogether. That means 5 are not right-handed. 8 wear specs. So 8 goes over here. That is for people wearing spectacles, glasses. The numbers who are right-handed and do not wear specs. So right-handed and do not wear specs. This is 19. 25 minus 19, that gives us 6. 8 minus 6, that gives us 2. And then this is 5. 5 minus 2, this gives us 3. 19 plus 3, that is 22. 8 plus 22, 30. 25 plus 5, that is 30. An adult is chosen at random from the group. That means the denominator is 30. Event X, the adult chosen is right-handed. How many right-handed are there? 25. So probability of X, 25 over 30. No need to reduce it. And then event Y, the adult chosen wears spectacles. How many people wear spectacles? 8. So 8 over 30. That's probability of Y. Now it's saying determine whether X and Y are independent, justifying your answer. So the justification that we give is this thing. That is of independent events. Let me write it down. So independent events, the only justification that we know of is that probability of A and B, or A intersection B, should equal probability of A into probability of B. This is the thing that we know of. So that means I need something that is related to these two. That is, the adult chosen is right-handed and the adult wears spectacles. So right-handed and spectacles. So this is the answer that we have. Let me draw the arrow like this. And that is this thing, which is 6. So probability of X and Y is 6 over 30. Now, does it fulfill this equation, which is right over here? 6 over 30, does it equals to 25 over 30 into 8 over 30? No, it does not equal. Therefore, it's not independent. That's all what we need. Now, let me ask a question myself. And that is about mutually exclusive. So if they would have asked about mutually exclusive event, or they can also use the term just exclusive. So for mutually exclusive event, the probability that both occurs, A and B, should be 0. So if I ask whether it's mutually exclusive, the answer is no, because yes, there are some people who are right-handed as well as they wear spectacles. Only if this thing was 0, I would say it is mutually exclusive. Since there is something in common, it's not mutually exclusive. So I've solved one other question for you, which might come in your paper in May, June 2025. And by the way, just a thought that 2025, this particular year, is a square year. It's a square of 45. So happy square year that is coming your way. So a very mathematical year. So now coming back to question number 8. It says in restaurant, 13% of the customers rated the food as poor, 20% satisfactory, 65 rated as good. Now there are 3 percentages. First of all, you realize that it's binomial, and whichever event they are talking about, we will use that percentage. If they talk about good, take this percentage. If they talk about satisfactory, take this percentage. If they talk about poor, use this percentage. A random sample of 12 customers who went for a meal at a restaurant was taken. Find the probability more than 2 and fewer than 12. Now this part also created an issue for a lot of people because of the inequality. More than 2 and fewer than 12. Now fewer than 12 does not include 12. More than 2 does not include 2. So basically this is 3, 4, 5, 6, 7, 8, 9, 10, 11. This is what you need to calculate. So that's so much of that. So what we do is that we calculate 0, 1, 2 and 12 and subtract. So people skip this out. And the probability is about good. Good is 65%. X follows a binomial distribution, 12 and 0.65. Always label the parameters. Probability X lies between 13 and 11. That's the same thing as probability X is lesser than or equal to 2. 2, 1, 0 plus probability X is equals to 12. This is for 0. This is for 1. This is for 2. This is for 12. Add it all up. Subtract from 1. And this answer is 0.993. Correct to 3 SF. So this thing is done. Now it says on a separate occasion, a random sample of n customers who went for a meal at a restaurant was taken. Find the smallest value of n. Now this is binomial and logs and inequality, for which the probability at least one person will rate the food as poor is greater than 0.95. Food as poor, that is the probability of success, 0.13. We don't know the value of n. We have to use logs. Probability X is equals to 0, NC 0, success raised to power of 0, probability raised to power of n, which simplifies to this. At least one of any event is 1 minus probability 0 of that event. This is at least 1. And this is 1 minus probability of 0, 1 minus 0.87 raised to power of n. This is greater than 0.95. So let me highlight this, the orange thing. 1 minus this thing is greater than 0.95. And let me put something in the middle like this. Okay, so now what we are doing is this thing, that we are solving this. The first thing that needs to be done is that 1 should be taken to the other side. There are 2 negative signs. Get rid of negative because we won't be able to use logs. So this is the first flip of the inequality. So let me write over here, this is the first flip that is done. And the next thing is that we take logarithm of both sides. It's your choice. You take log to the base 10, which is called common log, or you use log to the base e, which is called natural log. And when we take log of both sides, we take this power down. And since in P1, log officially is not there, we are using it for our convenience. Some people, they use trial and error, which is a waste of time. So this n comes down. This is log of 0.87. Log of 0.87 is negative. Log of 0.05 is also negative. So now when the coefficient of the variable is negative, the inequality flips, irrespective of whether the other side is positive or negative. That's not our concern. N is greater than 21.51. N equals to 22. Let me draw a number line over here and let me explain you this idea. So this is, let's say, 20 and 21 and 22 and 23 and 24 all the way till infinity. Now, when we say n is greater than 21.51, we are going in this direction. So lot of options are there. Out of these options, which one is the least value? Which one is the smallest value? So the smallest value is 22, and that is exactly what they have asked. So that's how this particular question is done. Question number 9. It says in the region, the total number of households in 3 villages are S and T. So always make a habit of just focusing on the first alphabet when we are dealing with a lot of names, R, S, and T. Each of the household was about the quality of their broadband service. The result was summarized as follows. So there were 3 kinds of broadband services. It could have been excellent, it could have been good, it could have been poor. There are 3 possibilities. Now it says find the probability that a randomly chosen household in Shan, so Shan is this thing, and has poor broadband service. So in Shan, the people who have poor broadband service, that is 40. So 40 is the numerator. And this is out of the whole group. So that is out of 800. So 40 over 800, 1 over 20, 0.05. This is exact. Otherwise, I would leave the answer in fractions. That thing is done. Find the probability in a randomly chosen household has a good broadband service given. Now this is conditional probability. Given that the household is in Shan. So how many people live in Shan? 223, 177 and 40. 223, 177 and 40. This is excellent. This is good. This is poor. They are talking about good. There it is. So 177 goes up. Again, leave the answer in fractions because this is exact. Now it says in the whole of this region Arca, there are a large number of households. A survey showed 35% of the households have no broadband service. So now this part has nothing to do with this part. It's all about over here. Now this is what? This is binomial probability distribution. This is the number of trials, which is 10. This is the probability of success that goes in this particular data, in this particular box that's right over here. Find the probability few of these households have no broadband service. So no broadband service, 35% has no broadband. That is the probability of success. I was just mixing it up. Yes, that is of no broadband. Probability x is less than 3. That is probability x is less than or equal to 2. So this is 0, 1 and 2. Calculate the 3 probabilities. Take care of the significant figures. And then you get this answer. So now that completes the paper. This is of 52 marks. And based upon the difficulty level, I think 40 marks should be there. 40 marks or above, that should be the threshold in percentile. And let me write over here percentile for getting an A in AS level in your upcoming exam. So now we have the mocks coming up. We have to do normal distribution. we have to do representation of data. And this I'm talking about an S1. The P1 video is already there separately. So now we have the mocks, and then we have the real CAI exam in May. So the following things needs to be done. When you observe my working, even though I'm a teacher, I do not skip any step. That is the main thing. Do not skip any step. I show all the necessary working, and everything is necessary. Now over here, someone can ask this question, that is it necessary to show this answer and this answer and this answer? No, it's not necessary, because you have written it down. You should write the 4 significant figure value, which I missed. Yes, definitely you should write, and then round it off to 3 SF. That is perfect. But writing every single thing, it's not necessary, because you are using a calculator over here. Similarly, when we talk about over here, this is better to write the value over here. Why it is better? Because otherwise you will forget to flip the inequality and you will be getting a wrong answer for this. Let me show you something over here. Over here, showing all the working. This is the equation that we are using. I'm writing it down. I'm multiplying these two. I can check the fractions. I can check the decimals. They are not equal. And let's say over here, everything in detail. Focus on the denominator because it's identical. Make sure that you write the probability properly. Make sure that if there is a need for reduction, then you do the reduction. So basically just follow the guidelines which I have given over here. So if you follow these guidelines, there is a very, very good chance that if you are all alert on the examination day, you will get your desired grade. So focus on, in AS level, focus on getting a very high A, because there are no A stars over here. So that when you go in A2 level and then you are studying P3 with maybe S2 or P3 and M1, so you are having a very good chance of getting an A star, and if you fall back, A is still there. So that's all from Shahab Yaqub. Stay tuned for more content.